let's get started on angle measure. That's what the first section here is. I can get to the top of my thing. All right, so the first thing we want to talk about a little bit is terminology for angles. So should have a couple of different pictures drawn on here. So as far as the terminology goes, what the definition of an angle, if you want to go for a geometric definition, is you've got two rays that intersect at their initial points. That's what an angle is. Okay. So as far as these rays go, that's going to be what we refer to as the vertex. You're probably already familiar with some of this terminology anyway, just to make sure we're all on the same page. So the place where those two rays intersect each other, we now refer to as the vertex. Okay. Again, we have sides of the angle, so this would be a side of the angle. This would be a side of the angle. If you've got points on there, maybe I put another point here, put a point here, and maybe I'll label it as A, B, C. If I want to refer to that angle in particular, defined by those 3 points, I use a little angle bracket, and you always put the vertex in the middle, so it would be angle ABC in this case, or if you want to write it the other way around, that's the same angle. That's all geometric perspective. We want to start doing what we refer to as analysis on some things. I know it sounds a little scary. Maybe don't think you go to the doctor. Analysis just means that you're trying to get as much information as you can about whatever object you're talking about. For analysis purposes, we mean functions. So we're trying to get as much information we can out of the function. So we want to start defining functions. Well, remember, functions take an input, get an output. Those inputs and outputs are typically numbers. So from our perspective, we need to start putting numbers in with our angles. Okay? We need to start getting some numbers in there. So to help us with that, we need to start talking about what we refer to as measures of angles. So going to my next picture here, I've got two different angles. Still on the vertex. Look, these angles I literally copied and pasted, so they should look exactly the same. Okay? But depending on how we start measuring things, things might change. Right? In particular, we need to talk about what we mean by getting a positive angle measure and a negative angle measure. So when we talk about measuring, there's two ways we could do it. We could talk about thinking rotating that way, right? I could spin to my left, or we could rotate that way and spin to the right, right? That makes a difference. If you think about if you're flying an airplane or sailing a boat, if someone tells you to turn 30 degrees, direction matters, right? Okay? Turn 30 degrees the wrong way, you're going to end up in a different airport. Okay? All right. So it matters which way we rotate when we start measuring things. So when we start measuring things for angles, I need to talk about where I'm going to start measuring and where I'm going to end measuring. Okay? So for angles, I said there were two sides, as we would call those rays. When we start measuring, we're going to be more specific. Okay? In this case, if I'm going to rotate counterclockwise, in this case, right, I went this way, the opposite way a clock would rotate, counterclockwise. This would be my initial side. I would start on that side to measure. This is going to be the terminal side. It would flip-flop in the other picture because I went from left to right rather than right to left, okay? So in this picture, this would be the initial side. This would be the terminal side. And again, all we're doing with this these words are saying, if I want to measure in the first case, I'm going to start measuring here and rotate that way. That's going to give me an angle. Right? The other case is just the exact opposite. Now notice they go in different directions. The angle itself has the exact same size, right? If I wasn't worried about direction, these angles would have the exact same measure, right? Like I told you, I drew the picture once and I copied and pasted, right? I'm going to try to reinvent the wheel drawing another picture, right? These should have the same measure, but it does matter now if I want to say I'm heading in this direction. Think about it again. Think about an airplane. If you're heading in this direction and turn that way, I end up going a different way, right? Turning this way would be a completely different direction. So that's all we mean by this initial side and which way are we turning. So that's how we're going to get our positive and negative angles. That's just going to tell us which way we're going to rotate. Okay? So by convention, we're literally making a choice. That's what I mean by that's what a mathematician means, whether they say by convention, it means you're making a choice. Okay? Literally is a choice you're making to make this definition. Okay? By convention, this is positive angle measure. If you rotate counterclockwise, that is a positive angle. This one is a negative angle measure. I haven't actually talked about how we get size yet, but this talks about direction. Okay? So you rotate counterclockwise, right to left, if you will. That's positive, left to right. Which, if you haven't learned it before, it feels a little backward. There are reasons why we do it this way, but it kind of feels backward. Because we read left to right, right? The positive angle measure goes, your number line is positive. You get more positive, if you will, when you go left to right. Okay. Feels a little bit backwards, but this is what we do. All right. So let's talk about how we get measures. There are two big ones that we'll talk about, and they're listed here on your page. There are two big ones that we'll talk about. There are others. In particular, if you do engineering, there's a third one that's called gradient versus the other two. But all we mean by a measure of an angle is we're trying to measure how much rotation there is. So that's exactly what the measure of an angle is. It's the amount of rotation about the vertex to move one ray, the initial side, to the terminal side. That's all we mean by a measure. Just how much rotation do you need? I'm sure you've done angle measures before this class, and I may be feeling like I'm a little bit pedantic talking about this in so much detail. But again, remember, our whole goal here is to try to make sure that we are all on the exact same page, that we're talking about the exact same thing going forward. Okay? So we want to make sure, mathematicians want to be very, very precise about things. They don't like having ambiguity, and sometimes that actually causes problems when you try to be precise. Okay? But we don't want any ambiguity at all. I shouldn't measure an angle and get 20, and you measure an angle and get negative 75. That would be bad, right? So we want to make sure that we're all on the exact same page of what we mean by angle measure, what we mean by positive, what we mean by negative, how much of a measure it is, and all those things. That's why we're setting it all down to start with. Okay? Plus, you got to start somewhere. Okay? All right. So that's all we mean is amount of rotation. So there are two standard ones that we use. Actually, in mathematics, the more standard one, if you will, is the one that you've never used in your life most likely. Okay? You're probably all familiar with degrees. We're going to use radians most of the time. The reason for that is, again, we're trying to get ready to do analysis of things. Calculus is the beginning of analysis. Calculus wants to talk about how things change, how functions change. To be able to talk about how trig functions change, it's a lot easier to do it in radian measure than it is degrees. That's why we're going to talk about most things in radians. Not that you shouldn't know degrees, because if you're going to go to physics class, you're going to do degrees at the wazoo when you're doing angles. Probably very rarely use radians. But it's important from a calculus perspective to do things in radians. So that's where we're headed. But again, like I said, degree measure is probably the one that you're familiar with. The idea, of course, with degree measure is that if you go around in a circle, how many degrees is it? 360, right? So circle is 360. Now, though, that we've done positive and negative angle measure, though, you should be able to tell me a positive or a negative idea. If I go this way around the circle, that would be positive 360. If I do this way around the circle, that's a negative 360. Right? So, again, when you do degree measure, it's dividing a circle into 360 equal parts. That's kind of funky, right? One of the reasons why 360 is used, at least, of course, it's all historical, so not 100% certain of anything. But the reason why we use 360, there's 365 days in a year. It's close to the 360. And notice that 360 is divisible by 1, 2, 3, 4, 5, and 6. Divisible with lots of factors, better than 365. So doing things in 360 parts actually lets you divide it up into even pieces a little bit more easily than if you did a 365 degree circle. Right? So for example, if you wanted to do a quarter circle, if I think about a quarter circle this way, how many degrees would that be? 90, right? Because that's divisible. It's just the 360 divided by the 4, right? Or if you wanted to do this, and I go a sixth of the way around, it's 60 degrees, right? I don't have weird fractions that pop up in those kind of even divisions of pieces, right? That's why we use 360 degrees. 360 because it's close to 365, but 360 has better divisors, essentially. If you go back to ancient Babylonian mathematics, they actually use a base 60 number system versus a base 10. The Babylonians, the Mayans, a lot of ancient civilizations knew there were 365 days in a year, but 360 was easier to deal with. For example, the Mayan calendar has 360 days plus an extra 5 special days. Anyway, probably don't care because you want to get onto the trig and I'll shut up. That's fine. All right. What about radian measure then? Well, rather than trying to measure based on kind of this arbitrary, I divided a circle into 360 parts, we want to do it in terms of lengths instead. Okay? Again, based on circles, but doing with lengths versus doing lengths versus just arbitrary division of all the way around. So the idea for radian measure is the following. I have a circle, and I have a radius of some certain length. Doesn't matter what the length is. Okay. I was trying to change the color. I keep doing that, and it makes it minimize. If I look at the arc here and go around this way and make the length of this arc also the radius, so the length of the radius and the length of the arc are exactly the same, that tells me that the angle inside here This angle is 1 radian. If you go through the book or other books and read about angles, this is referred to as a central angle of the circle. The vertex of the angle is at the center, so it's a central angle. We talk about this arc of the circle being subtended by the angle, the central angle. Subtended by just means it's the arc that corresponds to that central angle piece. So you see subtended, that's what that means. I don't particularly like that word. Not me. Choose. Anyway, so when you have an arc that's subtended by the central angle, where the length of the arc is the same as the length of the radius, then you get 1 radian. And notice it, since all of you, I'm sure you've heard about similar triangles or similar shapes in geometry. All circles are similar. They all look like a circle, right? No matter what size of circle you have, that radius, that radian measure wouldn't change. So it doesn't matter what the size is. Okay? It's not dependent upon what the radius is. Basically, you're just dividing it out, right? You're doing arc length divided by radius. That gives you the angle. We're going to actually use that when we come up with an arc length formula here a little bit. Maybe when we come up with the arc length formula. But in any event, that's how we get radian measure. All right, so one of the natural questions is, I have this new measure. What does it mean for us going forward? But also, how does it relate to the measure I've talked about before, that I've learned about before? Like I said, you all, I'm sure, have done degree measure. Okay? Maybe not radian measure. Okay? So how does that relate between the two? Well, let's think about it, a kind of an easy conversion, if you will. We already said that all the way around the circle was 360 degrees, right? Let's take a special circle and figure out all the way around. What if I have a circle and its radius is 1? We refer to this as a unit circle. Any circle that has radius 1 is called a unit circle. There's an entire approach to doing trigonometry from a unit circle perspective that I don't like, so we're not doing it. But I will just tell you what a unit circle means. It's just a circle with radius 1. But I should be able to figure out how long it takes to get all the way around the circle in terms of circumference, right? Radian measure is in terms of length. In terms of degrees, all the way around is 360. In terms of length, if I go here and go all the way around, how long did I go if the radius is 1? So remember your circumference formula? Yeah, it'd be 2 pi because the circumference is 2 pi times the radius, right? So all the way around, your circumference, is 2 pi times the radius. In this case, the radius is 1, so we just have 2 pi. So all the way around the circle is 2 pi radians. Again, like I said, I mentioned this a minute ago, all circles are similar, right? If I had a radius of r, all the way around the circle would be 2 pi r. I would divide out the r's and get 2 pi for the radius. Okay? So it doesn't matter what the circle is, radian measure will be 2 pi. Okay. Well, we just said all the way around the circle is how many degrees? 360, right? So 2 pi radians must be 360 degrees. That's our magical conversion, if you will, from degrees to radians and vice versa. It's stated a little bit differently since I actually have an equal sign here. I can divide both sides by 2. And we get pi radians, and I'll just write RAD for radian, is 180 degrees, which makes sense, right? 180 degrees is halfway around the circle. Pi is halfway around the unit circle. Okay? So this is how we're going to convert from degrees to radians and radians to degrees, going back and forth. So if we look at this first example here, convert these angles or change them over to radians. So notice that I want to start with degrees and end with radians. So if I have 45 degrees, when I do a conversion, I want the degrees to cancel and radians to come out, right? If you've done any chemistry, you've probably done some unit analysis types of things, right? Cancel some things out, okay? I want the degrees on bottom, the radians on top. Well, we just said the conversion's this one, right? We want pi radians on top and 180 degrees on bottom. Notice that I'm multiplying by 1. Those two things are equal to each other, aren't they? Pi radians and 180 degrees are the same thing from a measure perspective. I'm multiplying by 1. So I haven't changed anything. I'm just changing the unit. 45 goes into 180 4 times. Pi over 4 radians. Now, radian is unitless. Okay? We say radian is a type of measure, but there's not a unit to it. Okay? So if you're talking about an angle and there is no unit symbol attached, in particular, if the little degree symbol is not there, the angle is assumed to be a radians. Okay? So I'll write that down because it's important. If no degree symbol angle is in radians, not degrees. Okay. Mainly, that just keeps us from having to write RAD every single time we read, right? Put a degree symbol if it's in degrees, no degree symbol if it's in radians, and then keep it straight. They don't have to write a bunch of stuff. Okay. Mathematicians are inherently lazy. Okay? They don't want to write more things than we have to write. So we come up with conventions, and then it keeps us from having to write things. This one okay? It's the same idea for the next ones. If we do negative 270 degrees, you're going to multiply by the exact same conversion. And then reduce the fraction. In this case, 270 and 180 both have a common factor of 90. So if you simplify that, you get 3 pi over 2. Now, whether or not I can do that arithmetic that quickly in my head is up for debate. But the reason why I knew those that quickly is because those pi over 4, the pi over 2, those type of angles are going to be special ones that we'll see here in a little bit. You should be able to do the next two as well. It's the exact same thing. Notice in these two, if I have a 570 degree angle, that means you've rotated all the way around the circle, right? And then rotated another, degrees like this, 360, 210 degrees, right? So you've gone, and you've gone positively. So from your perspective, you would have gone this way, 360 degrees, and then another 210, somewhere down here. So I started here. The negative angle, you'd have to go around, what, 3 times? 3 times 360 is 1,080. So you would go negative, so you go this way, 1, 2, 3, and another 75 degrees. So that would be what that one would be. If you're thinking about where you would end up. I'll leave those for practice as far as getting the numbers, but I just wanted to give a little bit of perspective of which way it would go, because we're going to talk about that concept here in a minute. If we want to go the other way, if you want to go from radians to degrees, if I start with 2 pi over 3, What do you think we'll multiply in this case? Instead of pi over 180, we'll multiply by 180 over pi, right? Your pi's cancel in that case. 3 goes into 180 60 times, so you end up with 120 degrees. Right? If you wanted to do negative 7 pi over 4, you would still do the exact same conversion. Again, the pi's cancel. 4 goes into 180 45 times. 45 times 7, I believe, is 315. And you would do the next ones the same way. Again, notice that in the next two, both of these are bigger than 2 pi. So you would rotate more than one time, or more, at least one time around and then farther, right? Questions on those at all? That okay? I'll leave the other ones for you for practice a little bit, but let's talk about standard position and coterminal angles here as we finish up today. Like I said, we'll finish this up on Wednesday. So standard position. So again, like I said, everything that we're doing here is getting us to a kind of a standard point where we can start talking about functions and then analyzing those functions, different properties of those functions. Okay? So that's why we're doing all this groundwork, if you will, to start with. All right. So part of the analysis that we want to do for functions, remember one of the first things you can ever do with a function when you first define it is graph it. Because one of the things that you see from a graph is a lot of its different properties, right? Where does it go up? Where does it go down? Where does it flatten out? Where does it cross the x-axis? Where does it cross the y-axis, right? There's lots of important things that you can get from a graph, okay? So when we're talking about putting something in standard position with angles, we're going to put it on a graph. Because sometimes the graph things up. So standard position, not all that complicated to get at. I put two pictures here, one just to represent positive angle measure versus negative. When you put an angle in standard position, you put the vertex at the origin, always. Vertex is at the origin. That's step 1, if you will. Step 2 is initial side always goes on the positive x-axis. So we're fixing a starting point, essentially. No matter what we measure, we're always going to start it from standard position. Okay? And a minute ago when I was standing here with my arm going around, notice I always started over here. And went up, and that was positive. Or to you, that was positive, right? This was negative. Okay? Because I was putting something in standard position to start with. Right? Sometimes teaching is great, but sometimes teaching sucks because sometimes I forget my left and my right when I'm doing the things for myself because I do everything opposite. Right? Positively sloped line for you is a negative sloped line for me, and vice versa. Okay. So sometimes I get things screwed up in my head. Well, that's not the only reason why things are screwed up in my head, but I'm going to go pull at that thread. Anyway, all right. So the important part here is if we pick a starting point, then measure depends on terminal side and which way you go. Okay? So terminal side here, if this would be your angle, if I go this way, is that positive or negative? It'd be positive, right? Because I went counterclockwise, right? So this would be a positively measured angle. If my terminal side, or excuse me, if my initial side is here, my terminal side is here, and we go this way, that's going to be a negative angle, right? We agree? So again, the terminal side is going to help us determine measure. But notice that, again, I kind of just picked arbitrarily which way I rotated, right? Instead of rotating up in the first one, I could have rotated that way, right? This red one is negative, isn't it? But I ended up in the same place. This is the concept of what's at the bottom here of coterminal angles. These are their terminal sides end up in the exact same spot. That's what we mean by coterminal. Okay? So two angles in standard position are coterminal if their terminal sides coincide. That's all we mean by a coterminal angle. So if you think about it from a geometric standpoint, one of the things in your geometry classes you probably concentrated on a lot was the idea of congruence, right? When are things exactly the same? Coterminal angles are congruent, right? From a geometric perspective, they don't look any different, right? What's different about them is their measures. So let's think about, just real quick, how we would figure out whether two things are coterminal or not. Notice I went this way for that one, or this way for that one. What did I make? If I think about, again, not worrying about the arrows, but if I think about this piece and put this piece together, what did I make? A circle. I've gone all the way around, right? So that's going to help us figure out when angles are coterminal or how to find the other ones, and we'll talk about that next time. Okay? That's where we'll start, all right? Have a good one. We'll see you on Wednesday. Again, assignment for tomorrow. Get into WebAssign. Do the getting started assignment. Okay? By 11:59. That's when all the homeworks are due, or 11:59 p.m. Have a good one.